Hi, my name is Wendy Q, and my project is the optimal efficiency of oil and catalyst ratio and the yield of biodiesel using transesterification. According to the Environmental Protection Agency, the total U.S. greenhouse gas emissions from transportation has increased between the years 2014 and 2016. This increase contributes to the depletion of the ozone layer, causing harmful UV rays to enter the Earth. Figure 3 shows a simplified version of the transesterification process. Biodiesel is a renewable fuel made from vegetable oils or animal fats that is used to run diesel engines. Transesterification is the process whereby biodiesel can be made using natural oil or animal fats, triglycerides, and alcohol in the presence of a catalyst to produce the biodiesel. A catalyst is used in a chemical reaction to assist and speed up the chemical reaction. This is while simultaneously remaining chemically unchanged until the end of the reaction it is used in. The time spent for a catalyzed reaction is much less than an uncatalyzed reaction due to the smaller amount of activation energy needed. Natural oils and animal fats are triglyceride molecules. Triglyceride molecules are made up of 3 fatty acids attached to one glycerol. The oil or fat thus affects the characteristics found in the resulting biodiesel. The main reaction for converting oil to biodiesel is called transesterification. The transesterification process reacts an alcohol, like methanol or ethanol, with the triglyceride oils contained in vegetable oils, animal fats, or recycled greases, forming fatty acid, alkyl esters, also known as biodiesel, and glycerin. The reaction requires heat and a strong base catalyst, such as sodium hydroxide or potassium hydroxide. The simplified transesterification reaction is shown in the video. Hossein et McLeod 2016 tested creating biodiesels from usage of waste canola oils to assist in the sustainable energy and environmental recycling process. Figure 4 displays the different parameters used in each transesterification. Shown are the multiple different alcohol to oil ratio combinations that were tested, including 1:1, 1:2, 1:3, and 1:4. Also, potassium hydroxide and sodium hydroxide were also tested as the catalysts, with different amounts for each catalyst as well. Figure 5 is a graph of biodiesel yields versus methanol to oil molar ratios. The graph shows that 1:1 methanol to oil ratio has the highest biodiesel yield percentage at 49.5%. Following that was 1:2, 1:3, and 1:4 at only 18% yield. Figure 6 is a graph of biodiesel yields versus rules of catalyst. The graph shows that when sodium hydroxide was used as the catalyst, a higher percent yield at 49.5% was found when compared to potassium hydroxide at 33%. Hossein and McLeod found that a higher alcohol to oil ratio and a lower amount of catalyst was the optimal combination needed to produce the highest volume of biodiesel. Biela et al. 2011 studied new methods of soybean meal processing and implemented multiple methods in soybean oil extraction, which simplified the process of biodiesel production. Their method, in situ transesterification, eliminated hexane extraction to remove the oil and combined extraction and transesterification steps to minimize the steps needed to synthesize biodiesel via a single treatment. Figure 7 shows a schematic that Biela et al. Followed. Soybeans oil extraction was done by Biela et al. Oil was extracted through mechanical presses, solvents, supercritical fluids, and microwave and ultrasound-assisted methods. Figure 8 shows the different particle sizes obtained after using ultrasounds and solvents against the soybeans. Figure 9 shows each combination and group that was measured and tested and the resulting mean square. In Biela et al.'s study, it was found through the significance shown that using ultrasounds and hexane solvents to extract the oil from the soybeans yielded the highest biodiesel volume. The purpose of this proposed experiment is to test for the optimal ratio combination of alcohol and oil and the optimal amount of catalyst that will yield the highest volume of biodiesel through the process of transesterification. It is expected that when a higher ethanol to oil ratio and a lower amount of catalyst is used in the process of transesterification, similar results found in Hossein and Mohammed's study 2016 will be seen, where the volume of biodiesel yielded is the highest. In this proposed study, soybean oil will be purchased from a local supermarket. Organic soybeans will also be purchased for oil extraction. Two different methods will be used. A manual mechanical oil press and microwave extraction will be performed, and these two methods and their biodiesel yields will be compared. The optimal ratio of alcohol and oil with two different catalysts, sodium hydroxide and potassium hydroxide, will be tested. The 6 experimental groups will thus be canola oil, purchased soybean oil, and soybean oil from microwave-assisted extraction or manual extraction tested with NaOH and KOH each. The volume yielded will be measured and compared against one another. Data analysis will be done using IBM SPSS version 24. Mean and standard deviation will be calculated, and a one-way ANOVA test followed by a post-hoc Cepheid test with p less than 0.05 will be done. Data will then be graphed using Microsoft Excel. Here's the budget, and here's the bibliography. Thank you for listening.